How are you? Okay, so let's recap from where we left yesterday during our class in basic science. Yesterday you learned about the marine ecosystem and the coral reef ecosystem. So can anyone elaborate on that? What are some of the importance of marine ecosystem?
It is habitat for marine organisms. It provides food, resources.
Very good. So it provides a habitat or shelter to most of the marine organisms, and it is a source of food to the humans as well. Today we'll be starting with strain 2, that is matter, and the first substrain there is investigating matter, and the objectives of this substrain is to investigate the structure of an atom, that means what the atom is composed of, and explain the properties of common elements in the periodic table. Outline the electronic shells and the examples of common elements and its electronic configuration. That means you'll be learning how to write down the electronic configuration of certain elements from the periodic table and how to draw their electron structure diagram. So the structure and constituents of an atom. The atom is a very small particle that is composed inside the matter. Atoms are made from three kinds of subatomic particles, and these subatomic particles are smaller than the atom. So the three subatomic particles of an atom is the protons, neutrons, and the electrons. So Nihal, could you just elaborate on what is protons from your last year's knowledge?
Positively charged.
So protons are positively charged, okay, and they are made up of the positive particles inside an atom. Let's see what are protons. Protons, these are positively charged particles which are tightly packed together, which has no in the nucleus of an atom. So in the nucleus, say for example, this is the nucleus. So these protons, these are positively charged and it is tightly packed inside the nucleus. The second subatomic particle is the neutrons. Neutrons, they do not have any charges and they are also found in the nucleus. Then the third one is the electrons. These are the negatively charged particles. So the electrons will be orbiting all the electron shells and they are negatively charged. Any questions so far? No? Let's move on. The protons and neutrons are heavier than the electrons. So the protons, say for example, this is your sodium ion. Sodium, there are 11 protons and 23 protons plus the electrons. So this is your atomic number and that is your mass number. So the number of protons in sodium is equal to 11. When we say sodium has 11 protons, that means protons is equal to the number of electrons. So protons is equal to electrons. If sodium has 11 protons, that means it is also having 11 as the number of electrons. Now let's learn how to find out the number of neutrons. Last year you must have learned through your teachers that the number of neutrons is equal to the atomic mass minus the atomic number. But that is equal to, so sodium, the atomic mass is the bigger number here. The atomic mass will be 2 times greater than the atomic number. So here the atomic mass is 23 minus your atomic number, that is 11, will give you your number of neutrons, that is equal to 12. Okay? Very good. Now let's see what is an atomic number. number is always denoted by the letter Z, as you can see in this chart here. This is the atomic number here. Atomic number is the smaller number of the atom, and your atomic mass is denoted by letter A. So atomic number is the number of protons in an atom. It determines the element of the atom. So which element will fall where in the periodic table? Any atom with 6 protons, that is carbon, regardless of the number of neutrons and electrons. So if anything has 6 as the atomic number, it will be carbon. If anything has 8 as the atomic number, it will always be oxygen. If anything has 12 as the atomic number, it will always be magnesium. Got it? Very good. Let's look at another example of how to calculate the number of protons, electrons, and neutrons. This time we will take magnesium. So magnesium, the atomic number here is 12 and the atomic mass is 24. So Nihal, what would be the number of protons here? Protons is equal to electrons. So what is the proton? What is the number of protons here? 12. Very good. And the number of electrons is also 12. And the number of neutrons will be. How have you found it? Very good. So the number of neutrons is equal to atomic mass minus your atomic number, that is 24 minus 12, that will be 12. Very good. The elements are arranged in the periodic table in ascending order of atomic number, so it is easy to find the name and symbol of an atom if you know the atomic number. If we look at the table, that is better, first of all, you have to know the best 20 elements. the atomic number and 24 as the atomic mass. So the number of protons in magnesium is equal to number of protons is 12, number of neutrons is equal to 12, and the number of electrons is equal to 12. Very good. Third atom there is sodium. Sodium is denoted by Na, that is the symbol for sodium, and the atomic number is 11 and the atomic mass is 23. Therefore, the number of protons in sodium is equal to 11. The number of electrons will also be 11, and the number of neutrons is going to be 12. Very good. To remember that your atomic number is equal to your number of protons, that is also equal to the number of electrons. Your neutron, it does not have any charge, and your electron, it is negatively charged, and in order to find your number of neutrons, you will have to subtract it from your atomic mass minus your atomic number. Then you will get your number of neutrons. Since you have learnt about these simple atoms, now we will move on to electron configurations. Before we move on to electron configurations, you should know the terms electron shells or the energy levels. For an atom, there are different energy levels, and these levels are denoted by the circles. So this is your first energy level, that is your second energy level, that is your third energy level, and this is your fourth energy level. And each of these energy levels, they occupy certain number of electrons in their electron shells. So according to Aufbau's principle, the first energy shell, it can only occupy 2 electrons. The second energy shell, it can occupy up to 8 electrons depending on the atomic number. The third energy shell, it can also occupy up to 8 electrons, and the last one, it can occupy up to 18 electrons. Understood, Nihal? Therefore, when we write the electron configuration, we use this principle 28818 to describe or to outline our electronic configuration. The outer shell is the valence shell. So this outer shell, the fourth shell, is the valence shell, which is present in the electrons. The way an atom behaves largely depends upon the electrons in the outermost shell. So this outermost shell, it will determine the behavior of the atom, whether it is highly reactive, it is neutral, or it is not reacting at all. So now let's see what is the electron configuration. It is a group of numbers which shows the arrangement of electrons in an atom. For example, the elements sodium and nitrogen. Remember sodium? So the symbol of sodium is Na. The number of protons is 11 and the atomic mass is 23. So when we write the electron configuration, we always use the smaller number or the atomic number. So if sodium has 11 as the atomic number, and according to our rule, we can say that the first shell can occupy 2 electrons. So the first shell will occupy 2 electrons, then we'll put a comma after that. The second shell can occupy 8 electrons. Now let us see whether these 8 electrons can fit in the second shell or not. So when we subtract 2 from 11, we get 9. Therefore, it can fit the 8 electrons. And the remainder is 1. 8 plus 2 is 10, and here it is 11. So 11 minus 10 is 1 in the third shell. Therefore, the electron configuration of sodium is equal to 2, 8, 1 and close braces. Understood? Let's do another example. We look at aluminum. According to our periodic table, when you look at the periodic table, you will see that aluminum is found in group 3, and the atomic number of aluminum is 13 and the atomic mass is 26. Therefore, in order to determine the electron configuration of aluminum, the first shell is going to occupy 2 electrons. Then again the second shell will occupy 8 electrons. 2 plus 8 is 10. 13 minus 10 is equal to 3, and that is your electron configuration for aluminum. Let's do another example of lithium. Remember, lithium has a very small atomic number. Therefore, the atomic number of lithium is 3 and the atomic mass is 6. Therefore, the electron configuration of lithium will be first shell 2 electrons, second shell only 1 electron, since it has a very small atomic number. So 2 plus 1 will give you 3. In order to summarize electron configuration, always remember all these numbers should add up to give your atomic number. And the last part of this class today is determining the electron structure diagram. So let us just use these examples to draw your electron structure. So first we'll do it for sodium. The electron structure diagram, it will be composed of the electron shells, and there will be electrons that will be orbiting that shell. So let's look at sodium. Sodium has 3 energy shells according to the electron configuration. So we will draw these 3 shells. This is sodium. The first shell will occupy 2 electrons. So we will put 2 heavy dots here. This is your first shell. Second shell, it can occupy 8 electrons. So we will draw 2, 4, 6, 8 electrons, and the third shell, it can occupy only 8 electrons. Remember, the number of the electron configuration, it will determine on the number of energy shells that an atom will have. Here for aluminum, the first shell will occupy 2 electrons. The second shell, it will occupy how many electrons? 8. And the third shell, it can occupy 3 electrons. So 2 will be paired and 1 will be a lone electron. Let's do it for lithium. Here, lithium, the first shell, it can occupy 2 electrons, and the second one, it can occupy only 1 electron. So that was all about today's class. Now I want you to attempt this worksheet, and we will be marking that in our class. You have to write down the electronic configuration of silicon, that is having 14 as the atomic number, and calcium that has 20 as the atomic number. Could you do that now, please? Remember, the atomic number of silicon is 14 and the atomic number of calcium is 20. So I want you to deduce the electron configuration for aluminum and silicon and calcium. The atomic number of silicon is 14. So first shell, it will occupy 2 electrons. Then the second shell, 8 electrons. 2 plus 8 is 10. 14 minus 10, the remainder will be in the third shell. Here, 2, 8, 4. Remember, I told you here, all these 3 numbers, it should add up to give you your atomic number. So the electronic configuration for silicon will be 284, since the atomic number is 14. Electronic configuration here, 284. Good. Now do it for calcium. So first shell can occupy how many electrons? 2. Second one, 8 electrons. Since the atomic number is 20, that means it will have third and fourth shell as well. So the third shell can also occupy 8 electrons, and the remainder is 8 plus 8 is 16 plus 2 is 18. So 20 minus 18 is 2. Very good. Let's discuss that question. Silicon, the atomic number is of silicon is 14. It is given in the question in your worksheet. Therefore, the first shell can occupy 2 electrons according to the rule. You can also see in this chart as well. The first shell can occupy 2 electrons. The second shell can occupy 8 electrons. So 2 plus 8 is 10. So 14 minus 10 is 4. And this third shell will occupy 4 electrons. Likewise for calcium. Calcium, the atomic number is 20. Remember, for this type of questions, either you will be required to refer to your periodic table, or the number of protons will given in the brackets. Got that? Remember, I told you that the number of protons is equal to your atomic number. So if 20 is the atomic number of calcium, that means your electron configuration will be first shell 2 electrons, second shell 8 electrons, then third shell again 8 electrons. So 8 plus 8 is 16, plus 2 is 18. 20 minus 18, the remainder is 2, that will be in the fourth shell. Understood now?
Yes.
Good. Then you are required to draw the electron structure diagram for these two atoms, silicon and calcium. Could you do that now? You just have to refer to your electronic configuration and draw the electron structure diagram. Very good. So I assume you have understood the whole class that was discussed today. So when we draw the electron structure diagram of silicon, yours is correct, I have gone through it. The first shell, it will occupy 2 electrons according to the electron configuration here. Second shell will occupy 8 electrons, so these will be all paired. And the third shell will occupy 4 electrons, that is also going to be paired. And the last one is calcium. So calcium, first shell 2 electrons, second shell 8 electrons, third shell again 8 electrons, and the fourth one will have 4 electrons that will be paired again. So that was all about your class today. I hope you have enjoyed it. Now let's summarize our topic for today. Remember, we learned about the 3 subatomic particles of matter, that is protons, neutrons and electrons. I have already elaborated that protons is always positively charged and they are tightly packed in the nucleus. Neutrons, they do not have any charge at all, however they are found in the nucleus as well. Then your electrons, these are negatively charged, and remember your protons is equal to your number of electrons, that is also equal to your atomic number. And then we looked at the example of sodium, how to determine the atomic mass and the atomic number here. So the smaller number will always be your atomic number and it is denoted by the letter capital Z. And your atomic mass is denoted by the letter A and it will be 2 times the atomic number. So here if we look at sodium, the number of protons is 11, since 11 is the atomic number here, and the number of electrons is also going to be 11 here, and the number of neutrons is equal to your atomic mass minus your atomic number. Remember, you will always subtract it from the bigger number. So 23 minus 11 will give you 12 as the number of neutrons in sodium. And then we learned about writing electronic configuration, and the example we took there is sodium again. So when writing electronic configuration, always use the atomic number. That means you are going to use the smaller number to write your electronic configuration. And for sodium, the electron configuration is 281 according to the rule here that you have learned. The first shell can occupy 2 electrons, the second shell can occupy 8 electrons, and the third shell will only occupy 1 electron, as this number is very small. So there is the rule for deducing the number of electrons in the shells. So in sodium, the first shell will have 2 electrons, second one will have 8 electrons, and the last one will have just 1 electron. And then we learned how to draw the electron structure diagram. So again we'll take the example of sodium. After you have written the electronic configuration, remember you cannot draw the electronic structure diagram without writing the electron configuration. Therefore, in order to draw your electron shells, you will have to first deduce your electronic configuration or write your electronic configuration. Therefore, for sodium, the electron configuration is 281. Therefore, the first shell in the sodium will have 2 electrons, second shell will have 8 electrons, and the third one will have 1 electron. Any question? Okay, I hope you have enjoyed the class, and you can refer to page number 35 of your textbook and do questions 2 to 6 as your homework. Thank you for listening, Nihal, and being so attentive and cooperating with me.